Hi, I just wanted to do like a introduction of my null-units system. So essentially, right now, the units are created, and there's a bunch of them in here, and you can load them in JavaScript on the web. But I have some plans for making a native one, and I've got like the start of it, but I need to finish it. Um, Essentially the idea is like you've got these like individual pieces, these blocks that are pretty simple. There's a header here for C, but you can make yours in anything you want. I was already doing C stuff, so it was easier to like, I don't know, stay in the same language. um, Essentially you just need to return a few functions. So these functions right here are like the things that you have to export in your engine. I've got some basic memory management. I've got an info function, and I've got like process, destroy, param set, and param get. So if you implement these in whatever language you want to use and compile to WASM, it'll work just like everything else. In the C stuff, I also added some extra headers, so you can kind of like um, it's a little easier to use it maybe to get started. But eventually, I'll try and port all these helpers and things like to other languages. You know, like it's pretty useful to make a triangle wave, for example. So making a triangle wave in assembly script is not really much more complicated than doing it here, or simpler. It's about the same. So I could, port each one of these little utility functions I use over there once I kind of figure out what people need. So far, these have been the ones that I've been like reusing a lot. So this is what I've got. So most of these are just kind of like simple building blocks. Like they're either an effect or some kind of sound generator. I don't have a lot of sound generators made. I think noise is in here, or maybe it's called static. Yeah, static. This is just a simple white noise generator, but you can use this as an example. See, it just outputs a random float. That's all it does. Um, and wavetable is a little bit more complicated, but the idea is like when it first loads, it asks for samples by number. So it'll say like, give me sample 0, give me sample 1, give me sample 2, whatever. And when it grabs those things, the type parameter will make it pull in that sample. So um, the samples are a simple format. They're just like 256 floats. And I've already in the host, I've already got it like loading up those samples like at the start. So it's like a shared sample system where they can, multiple units could use the same samples from the host. That's the idea there. And so you can see how to use it, but you can set it up however you want. This is just one like simple example. I wouldn't even recommend really using this because it just kind of creates like dumb oscillators, and you can get better ones if you just use like in the host, if you just use the OSC, which is like the generic oscillator. And here's an example of doing that. So you can just load an OSC unit, and this actually comes from the host, not from a unit. And this comes from a unit, and these two come from the host. And so anyway, you can mix and match things however you want. But yeah, a lot of this stuff is just kind of like examples of how you might want to set it up, but it's not necessarily like a full-on thing. The TR-808 is a pretty good analog drum machine, I think. Like you can kind of make sounds from any of those old analog drum machines from like the early 80s. It's called TR-808, but it's not really a perfect 808 or anything. But it has all the elements. So if you set the parameters right, you could probably get something that sounded pretty much like an 808. Like it even has like slight distortion for adding like the kind of like analog noise you get on a TR-808, and it has a low pass filter to sort of simulate like caps, like the capacitors that sound is running through, and it kind of mutes the sound a little bit. But anyway, so do check that out. It's got a lot of options, but this is a way more complex example. And there's a lot of setups, but you can kind of see what I did. So these are, this is like, I want a MIDI float, which is like 0 to 127 in float format. So you can do like between notes. You can do like, 1.5 message, and it's in the range of 0 to 127. And I try and do that all the time, to keep everything like uniform, so it's easy to like hook up to MIDI controllers and things like that. But I think a few of these units I need to work on. They're not like in that range, but for the most part, that's what I'm shooting for. And the same thing with like notes. Like if you're going for a frequency, it'll always be like or it always should be 0 to 127. And that's just like the MIDI note range. So you can count on like 60 being middle C, for example. Okay, so yeah, this one's a lot more complicated. I wouldn't really base much off of this. It could probably be improved a lot, but you can kind of see how I put it together. If you want a simple one, copy is like the simplest. It's basically like no parameters, just like take the input and spit it to the output. There's some other ones too, like low pass filter is a good example. I use this a lot as my starting point. It's basically just the same kind of thing, but it's got one parameter. Super easy. If you do need like a more custom parameter, like I made a little helper just to generate like little float like control messages, and just to make it easy on myself. But if you need like more complex stuff, the full format is in that header file. So it's in here, and it's these like things put together. So this is what you're like returning. This is how you track like a parameter. And so like an example, I think I did some in here where I manually made them. Yeah, here's one. So instead of using the helper, this is min 1, max 4000, and it's a float. So this is very similar to one of those float MIDI things, except the range has changed. And another thing you can do is you can use the helper to generate the thing, and then just change like one or two things if you need to like just change one thing. Here's another one that's like more, it's a mix. So I have one parameter that's a handmade like float parameter, and then this one's like using the helper. Let me see if I can find one that's a little better. Yes. Okay. So this is a good example. So I generate, because there were so many different parameters for the drum machine. I generated them all as MIDI because that's like the starting point. So 0 to 127 float. And then I wanted to set the value, the initial value, to something useful. So if you hook it up, it'll immediately make sound, because a lot of these things are like, they're kind of like, they're very noisy or don't make any sound at all if all the parameters aren't like, set up in some way. Kind of like, working with analog stuff, it can be similar. You have to make sure you have the volume turned on and things like that. So this is a whole bunch of stuff where I'm just setting the initial value of some MIDI effects. By default, they're 0. So I set the initial value. And then I'm doing the same thing here. So I set like, I set up some initial like structures that have all the information about what's needed to make each type of drum. You can combine these ideas however you want, but I so far this has pretty much been how I've been doing it. So here's how to use it. So once you've made all this, right? Like once you've made your units, if you just use the project that I've got, the thing here, you can see all the effects I just build like this. So if you make something that's like build : whatever, and then put it in here, it'll automatically work with build, because this just runs all of those. And you can see my make file is very stupid simple. It basically just outputs WASM in the docs folder, docs units. And so that's the output product, and this is what I would share with people if they need an effect. These are binary files, they're WASMs, they're just ready to go, and they should run in any host. So you can download the collection of WASMs and use it immediately however you want. In this case, I have some examples, and I have I think a pretty good manager class that like takes care of it for the web. So here's a simple example, simple HTM. You can see that it's just an oscillator that goes into a scope and a pitch detector. So this detects like notes. And I use this kind of setup a lot to like check effects and see how they're working. I don't really need the pitch thing necessarily, but the scope and an oscillator, those two things together, if you put the oscillator into if you connect it to a new effect that you're working on, you can look at the scope and you can see like, oh, I see it. It's doing what it's supposed to. And so the way that you connect things is it's basically like from and to. So you just connect each thing from something to something else. And there's other parameters, like if they have multiple ins and outs, you can define the ins and outs, but this is the default. Just like connect like whatever makes sense between these two things. So that's the basic usage. And then if you look at index, you can see this is a more complicated example where I sequence things in JavaScript. I sequence a beat. That's what this is. So basically I'm just sending note messages to the TR-808, and each one of these numbers corresponds to like a drum machine. You can look that up in here, but it's the standard MIDI numbers that are on every drum machine. So it should be pretty familiar, but it's also in here. If you go down to the switch statement down below, you can see, yeah, here it is. So here it switches between the numbers, and you can look up what it is. But this is just a standard MIDI drum kit, so you can find that reference on the web. It's pretty standard. But 35 and 38 are your kick and snare, and hi-hats 42. Those are probably the things you need to remember. Okay, so if we look at this slightly more complicated example here, you can see first I load a bunch of things, a bunch of units. Now, most of these are actual WASM units that came from here, but a few aren't. Like scope comes from the host, and here's another scope. And I don't have OSC in here, but I do in this Rickroll. This is another simple example, but it shows how to play like music. Like this is notes. And it'll play Never Gonna Give You Up. Okay. So if we go here, there's lots of built-ins, or there's a few built-ins, those three things, and you can find that in the units.md. They're all referenced, and you can find out how to hook things up, and there's descriptions of like what kind of sounds you can get from each thing and all that kind of stuff. But yeah. Anyway, so first you load a bunch, and each one of these returns a number. And so even though I'm calling it OSC here just for reference, this is really a number. In this situation, it's actually number 1 because it's the next one that I connected after this, but you don't really need to know that. It's just helpful to know that these are numbers, so when you're passing them around, you could actually just use a number instead if you wanted, if that was easier. Or if you had all these in an array, you could use like array keys or something. Whatever makes sense to you. Audio out is always 0, and that's like built into the engine. So anything you connect to 0, here I'm using audio out because it's a nice label, but I could just put 0 here and it would do the same thing. The same is true here, like because this is the first one, this is probably 1. So instead of OSC, I could just put 1 right here. Doesn't matter. I'm just using variables to make it easier to read. So then I set up some initial values, and this overrides what the unit itself has built in. I try and make most of the units have built-in like sensible values to start, or at least like something that'll make noise, so you know it's like working. But sometimes you want to like tune it. So here I'm kind of like tuning things to sound good when it initially first loads up, and it uses the full label name of the thing. And so you can get this information if you do units get info and then the number, or the identifier, the unit ID. You can do it that way, but you can also just, if you run the UI like this thing right here, this builds an entire web UI for you, and you can. That's what I use to like reference everything. It makes it really easy. You can also override the titles of anything. So if you have multiple things and you want them to like differentiate, like I don't want these to both just say OSC. I gave them different labels so that I can see in the UI. I can see like, well, what is this scope for? Like, what does this actually output? And the UI builds everything from the order that you loaded stuff. So you can mix and match the order here to get them to load in different orders. I try to make it as simple as possible, so there's like not really anything you can configure other than the regular synth stuff, which is like set parameters, load things, and that's it. Okay, so that's the initial like setup, and then you want to connect all your units to each other. So here I'm connecting the ADSR to the scope oscillator, scope OS. Yeah, so this is the oscilloscope for the oscillator, which is like the source sound. And then I'm hooking up the os to the pitch detector as well, and the os to the ADSR. So this creates something that looks kind of like this. OSC, ADSR, scope, OSC, OSC, pitch. And so on. So each one of these connections, that's how you wire stuff up, and it's all like 1-to-1. So even though there's like 3 here, you have to do this in like 2 separate messages. So OSC to ADSR and ADSR to scope, that kind of thing. So you can do pretty complex stuff. You could even wire things into themselves if you really wanted to, but you probably don't want like feedback loops like that. I don't know. Maybe you can make some cool sounds with that. Okay, so, and then again, this just adds the UI for everything, basically. So make sure you set any titles that you're going to do before you set the UI, because it's not aware, like if you change the title, it doesn't update the UI. The UI is meant to be very light and simple, so there's not a lot of like updating code. It updates with parameters just so you can see what's happening, but that's about it. And then this is a little bit weird, but if you have scopes, they need like to periodically be updated so that you can show stuff on the screen, or like the pitch detector also is the same way. And so this basically just sets that up. This like calls it every frame and like asks those things to like do their update function or whatever. And then again, I made a little helper here so I can like write beats like very simple. So these are like the TR-808 like letter combos. So I've got, bass drum, snare drum, closed hi-hat. I always mix up CP and CL. I think CP is cowbell for some reason, and CL is clap, but whatever. Okay. So then if you look at this beat, you can see I just used standard JavaScript stuff. I used a set interval, and this like uses a BPM formula to take this BPM and turn it into like a beat, right? So if we watch all this together, you can run npm start. And you get this page. So we have a little click to start, and the reason is because of web security. So you can't just start making noise. You have to respond to user interaction. So we do this, and now we've got a pretty simple setup. You can see that it maps pretty closely to like what we did up here. So we've got the order of everything follows this. So we've got wavetable is the first one right here. ADSR is this one. Gain is here. Scope is here. We've got pitch, which is this pitch detector. LPF is Moog LPF here. And so on. So this is the full final output, and you can see it use those title labels so I can see the source sound that's coming from just the oscillator before it goes into effects and things like that. And then also I can see the final, what does it look like all together. I've got this drum machine running through distortion because I think it sounds crunchy and good. You can turn up the crunch. And this highlights some weird areas. So I haven't really made all these like bulletproof yet. And I remember using old like LADSPA effects that were not bulletproof, and I would get really interesting sounds out of them that are, were things that like the original person maybe didn't intend. And I kind of like that, but it can be pretty annoying if you hit a spot where this unit goes dead. It's possible to like crunch it out, give it an invalid value or something like that, and it'll like freak out. I'll try and harden up the effects a little more so they can recover from that situation, but here, let's see if I can create that problem. I might be able to... Yeah, it looks like if I turn the crunch up and I turn the tone up and I go to type 4, it basically kills the distortion. And since the drums are going to the distortion, it kills the drums. Now, it's fine if you just refresh, it comes back. Everything's back to what it was, but that could be a little bit frustrating. I might also make some way to like turn things on and off, like to give them a quick reset, because if you put this back into a state that like made sense, like go back to type 0, it might fix it. You know what I mean? So like so you could turn it off and you can turn it back on, and it would probably fix it. So I'll work on that. I think that's in the works. But yeah, this is basically like a simple assembly of a whole bunch of stuff. And you can see my Rickroll here. And all these are little, independent units, and you can just hook them up however you want. You can mess with them on the fly if you want. The whole UI comes from this one line here. And the thing that makes the scopes work is this. So you probably want this and this together to make a UI. But other than that, you don't really need anything else. And what else? I guess that's it. Just read the units file and this units.md, and you should get a pretty good idea of how all this is. And this looks nicer on GitHub. Like if you go here. So yeah, you can just kind of look through them all. I don't have clear definitions for like parameters and things like that, and I only have the specific unit name, so you know how to load it. And the reason for that is that I'm still kind of building everything. I'm putting it together. So for now, what you can do is you can load anything and do a get info on it, and it'll give you the info about all the parameters, and it'll tell you like the ranges and the names of each parameter if you want to like call them by name, that kind of thing. But overall, yeah, I'm still trying to build things up, but doing a get info looks pretty much like this. So it'll give you everything you need to like figure it out. And this is a snapshot in time, so it gives you like what's it currently set to. So you can also like pull the values of any parameter that way, which is pretty nice. The types, that's one thing that maybe is a bit unclear. The types for each one of these fields is this enum, and it's basically just I wanted to support just numbers, right? So I took the most common parent like number types, and even Boolean is still just stored as a U32, but yeah, these are the types. And the reason I mark it this way is so that I can put a checkbox on it. So that's how like the trigger works, for example. If we go here, that's how this trigger works. So if I turn this off, I can trigger it on and off like that. And so that's just because it was marked as a Boolean, not just like a regular number. But when it stores it, it actually just stores it as a number. It's just 0 or 1. Okay, so yeah, I think that's most of everything. I am very open to PRs. So if you can think of any improvements to any of these, I'm sure there's tons of problems with all of these effects. I'm no expert at audio programming. I just kind of piece this together from like reading Wikipedia and trying to figure it out. Looking at other effects, like looking at LADSPA plugins and things like that. So yeah, this is probably not great. Not a great collection. It could use some work. Um, but in addition to that, I would also like to see more effects in other languages. So like I wrote all these in C, but they could be written in literally any language that compiles to WASM. So, people could write effects or units in, like Go or in assembly script, which is basically like, TypeScript. Or I don't know. There's a really good language, Walt, that's very similar to JavaScript. That's extremely lightweight, and you could write really nice plugins in that with no overhead. So, and it's a joyous language. It's very fun to program in. I think there's like a MicroPython build for WASM that would work okay. You can use Nalua, which is like compiled Lua, Rust, really any language. There's like so many languages, and they all output the same format. So once you compile this, you can give this to all your friends, and they can use these things to make their own synths. So yeah, so I think there's a lot of there's a lot of strength in diversity of languages, and like trying to have like a kind of a big list of different types of effects written in different types of languages, I think would be really useful. Even if it's just like a re-implementation of exactly the same things, like a low-pass filter in like 40 different languages, I think that'd be cool. That'd be useful. All right, well, I think that's it. Have fun.